Hello everyone, and a very warm welcome to today's PV Tech webinar with Trina Solar, where we'll be learning about advances in N-type solar PV technology and how to navigate them. I'm Andy Colthorpe, Deputy Editor-in-Chief at Solar Media, which publishes PV Tech alongside our other industry-leading news channels like Energy Storage News. Now, in my job, I'm very lucky to have the opportunity to see and learn about some of the clean energy technologies that are changing the world and creating a positive revolution in the power sector. Working with leading companies like Trina Solar puts us in a privileged position of being able to bring you a close-up look at cutting-edge technologies as they go from laboratory-based innovation to mass production and deployment at gigawatt scale around the world. Over the past couple of years, N-type TOPCon, or tunnel oxide passivated contact photovoltaic cell technology, has emerged as a leading contender for powering the solar PV plants of today and tomorrow. It's been really exciting to see how that technology is taking hold in the market, and many capacity expansion and factory plans from leading and established manufacturers to startups have been covered by our team at PV Tech. Today's webinar gives us a great opportunity to dive into N-type TOPCon as we look at efficiency increases beyond the theoretical limits of other solar technologies available today, and how both high quality and high performance can be reached and maintained through smart production on a mass scale. Trina Solar is particularly well positioned to talk about this, with the company's N-type iTopCon advanced cells and modules already rolling off production lines, while Trina Solar has been first to market with a large format N-type module with output exceeding 700 watts. What's also really important, along with efficiency, is reliability. Many modules may look the same, but close analysis shows that this is really not the case. So we're very lucky that today we are joined by experts from PV Evolution Labs, PVEL or PVEL if you like, and TÜV Rheinland, who will share their insights into how solar cell efficiencies, reliability, and other key metrics should be thought about. Now, today's speakers are Theo Jin, who is Manager for Global Product Management at Trina Solar. We also have Tristan Erion Lorico, who is VP of Sales and Marketing at PV Evolution Labs, and Jason Chigao, who is Technical Expert at TÜV Rheinland. Today's webinar will take the format of presentations from our speakers, followed by a short panel discussion in which I will ask some questions. But then, as always, interaction with you, the audience, is really important to us. So please put your questions for today's speakers in the questions tab on the right-hand side of your screen, and we will do our best to answer them in the Q&A session at the end of this webinar. We won't be able to answer all of them during the broadcast, but Trina Solar will be happy to reach out to you and continue discussions offline after the broadcast conclusion. So, without any further ado and no more preamble from me, I'd like to hand you over to today's first speaker, Theo Jin. Theo, over to you.
Okay, thank you, Andy. Hey, good day and good evening for everyone. Thanks for joining this webinar. Now I will give you the presentation, Trina's iTopCon and Vertex N-type product roadmap, 2 and 10 with N-type leading the time of solar energy. At the very beginning, let's look back at the history of PV LCOE. It has continued to decline in the past decade, which can be clearly seen in this chart, from about $300 to $45, 2010 to now, the LCOE of large PV power plants in the world has declined by 84% on average in this decade. However, in order to accelerate the replacement of fossil energy, the PV LCOE still need to reduce continually. Then let's see something about the cell capacity worldwide. The left part is the production capacity of the solar cells, including P and N type. The right part is the high efficiency cell capacity forecast. There are many BC types and AGT, and of course, including the TOPCon technology. We can see it's very directly from the both. From this year, 2023, N-type capacity will exceed 50% of the solar cells, while TOPCon cell capacity will reach 19%. After the last generation PERC technology, apparently, TOPCon is becoming another mainstream of the cells of technology, which is already proved by industry right now. Trina Solar started TOPCon research as early as 2015. In this year, besides on the Trina Solar's state key laboratory of the PV science and the technology, iTOPCon lab was established. And during this time, the very first generation iTOPCon cell efficiency is 0.2% better than that of the products in the same time. The mass production efficiency was up to 23.5%. And with 500 megawatts production line. The two top runner projects during this period witnessed the success of iTOPCon 1.0. Then beside on 210 wafer, Trina Solar developed the iTOPCon Plus technology, efficiency broken the record 3 times up to the 25.5%. The average mass production cell efficiency also up to the 24.5%. When the times come to the 2023 this year, Trina published the 3rd generation TOPCon technology, iTOPCon Advanced. The cell mass production efficiency can reach 25.5% and has already in mass production. The capacity up to the 40 gigawatts for the 2023 for the whole year. And most importantly, with iTOPCon advanced technology and 210 rectangle wafer platform, Trina developed a whole Vertex N type N module product family. And of course, Trina will continue working and upgrade such as iTOPCon Ultra and Tandem technology may come soon in the future. Besides on the iTOPCon technology and 210 rectangle wafer size, now we have the Vertex N type product family. You always can find a right product in all scenarios, no matter rooftops, CNI, to residential, and to utility scenarios from the left to the right. Vertex S Plus, the NEG 9 ARM.28 for the rooftop, medium size of the NEG 19 RC.20 for the CNI, rooftop, and utility sometimes. And of course, for our biggest one, whose power could up to the 710 watt for the utility, mainly NEG 21C.20. Prospectively, for rooftop, we got Vertex S Plus beside our 210 rectangle cell platform, 48 pieces of the cells golden size, and with the 2 square meter of the size limited design. In addition, the 1.6 millimeter lightweight double glasses design blocks the aging factors such as acid, high temperature in the environment, further improving the reliability of the module. The weight of the 21 kilogram is also easier for handle and installation. While this small size has a bigger energy, compared to the previous generation of the products upgraded from the iTOPCon Plus to the iTOPCon Advanced, its power increase from 410 to 450 watt, as well as efficiency to up to 22.5%. We have an example project here. Compared to the reference module, the results show that the power generation is better around 5.9% compared to last generation. And the medium-sized NEG 19 RC.20 is also based on the 210 rectangle wafer platform upgraded from the iTopCon Advanced. The module power is up to 620 watts and efficiency up to the 23%. The design of 2382 millimeter with 1134 millimeter can maximize the use of a container space and to have the better performance on the BOS saving compared to the traditional module package, can increase the loading capacity of 5.2 regard to the total power for each container. The last production is our start of the LCOE. The NEG 21C.20 is designed mainly for the utility. Besides on the 210 millimeter wafer size, the power of this bigger one upgraded from 695 to the 710 watt with an efficiency of the 22.9%. We have a 210 half-cut cell and bifacial dual glasses design. Compared with others conventional products in the solar industry, it could bring better customer value no matter on the power generation and LCOE. And there are two BOS and LCOE assessments cases. The first one is about our medium-sized NEG19 RC.20 product bifacial module. The project is located in Dubai, and the AC capacity is 4 megawatts. Since Trina's product the lower open circuit voltage desire, so when in same AC capacity project, there could be more module for each string of the Trina's module compared to the others PV modules. So in this case, the same AC capacity, the string number will be less. As a result, the value assessment shows the Trina's module have better performance on the BOS saving of the module installation, electrical system, as well as tracker and transportation. Overall, and compare with the reference module, the Vertex NEG19 RC.20, this module in this case has lower LCOE result in this assessment case around 1.2%. And the second assessment is about our Vertex NEG21C.20, the bigger size product for the utility mainly, same as the last one. The design of lower voltage means more module for the each stream and less strings in same AC capacity project. Overall, the results show of NEG21C.20, the product module performance better than 1.1% in LCOE. And finally, I want to show the manufacturing capacity of the Trina. We have the manufacturer basis in our HQ Changzhou and same province Yancheng, Huai'an, Sutian, south part of the China, Yiwu, and a new one in western part of the China, Qinghai, as well as overseas in Thailand and Vietnam. The Trina's module capacity could up to the 19.5 gigawatts and the cell capacity 75 gigawatts, including 40 gigawatts of the iTopCon. Ingot capacity is also up to the 50 gigawatts. And well, here's my presentation. Thanks for your attention.
That's terrific. Thanks very much, Theo. And yeah, very nice presentation, and great to see the roadmap in action and seeing that progress, I think, in the development of solar technology. So we already have some great questions from the audience, so thank you very much for taking part. We'll be trying to ask some of those, as I said, in the Q&A at the end. But let's move on to our next speaker now. I believe that would be you, Tristan. So if you'd like to put your camera on, share your screen, and fire away, I guess.
Hey there, can you hear me okay? Hope so.
Yeah, loud and clear, yeah, no problem.
Okay, perfect. Well, first of all, thank you to PV Tech and for Trina for having me today, and thanks for everyone who's attending. For those of you who don't know us, PV Evolution Labs, or PVEL as we're known in the industry, is the independent lab of the downstream solar market based in California, USA. Our mission, as shown on screen, since our founding over 10 years ago, is to create the data that matters for solar and storage adoption. We're probably best known for our annual PV module reliability scorecard that gets downloaded and accessed by, last year over 35,000 different people across the world. And I'll be speaking about the scorecard a little bit more shortly. So as you can see on the screen, we provide a wide range of services to the industry, all of which are focused on advancing our mission. We work with companies all over the world, including banks, developers, asset owners, insurers, etc. We call them our downstream partners. There's over 400 downstream partners signed up in the PV and storage stakeholder community, and they use our data to help de-risk their procurements and projects. And as it states on the bottom, in 2021, PVEL became part of the Kiwa Group, and along with our sister company, PI Berlin, we offer a full range of due diligence services to module purchasers, including testing, factory audits, in-factory production oversight, data services, market intelligence, etc. Okay, so our flagship service for the solar industry is our Module Product Qualification Program, or PQP. A key principle of the PQP is that it's regularly updated to provide module buyers with consistently relevant data as new technologies such as TOPCon and manufacturing techniques are introduced in the industry, as well as new failure modes in the field start to develop. The current test plan for the PQP is shown on screen, although we are releasing an updated PQP test plan in the coming weeks. The PQP generally includes a number of tests designed to address a range of known PV module failure modes, as well as in-depth module characterizations at different irradiances and temperatures and different light angles. These tests go beyond what is required for basic PV module certification to help better understand how the modules will perform over the lifetime of the PV project. You can see at the top here, there's a factory witness box or a factory witness statement. PQP participants submit factory witness samples for all of the tests and reports that are developed across the project's duration. So we go to the factory and we see the modules being made before they're shipped to PVEL's labs. Then the reports are released, and those are available free to PVEL's downstream partners. And as I mentioned, they're used by financial institutions, independent engineers, developers, etc., to approve the module selection in the projects that they finance and that they build. So if you'd like to sign up for a downstream partner, please contact us via our website, pvel.com. Okay, so back to the scorecard. You can see the front of the 2023 scorecard executive summary on the screen there. Within the scorecard, we list manufacturers and PV module models, the specific models that are considered top performers. So, and you'll also see that top performer mark on data sheets and in marketing materials for the module manufacturers that are listed as top performers in the scorecard. So to become a top performer, the manufacturer must have completed the PQP sample production factory witness within 18 months of the scorecard publication. And they must have submitted at least 2 factory witness PV module samples to all the PQP reliability tests subject to our BOM test requirements. To be a top performer in one of the showcase reliability tests, manufacturers must have less than 2% degradation after the test and not experience a wet leakage failure, which is an electrical insulation test, or a major defect during visual inspection as defined by IEC 61215, and they can't experience a bypass diode failure for that particular test. So the level's pretty high. Just to build off this, for certification, you can, with much shorter test durations, you're allowed up to 5% degradation for your products to be certified. So for the scorecard, we extend those test durations, or we combine different tests, and you have to have less than 2% degradation to be listed. And to be listed as a PAN top performer, and that's the module based on module performance and energy yield, modules must place in the top quartile for energy yield in our PVSys simulations when using the PVEL measured PAN file. So as this webinar is focused on N-type technology, I thought it would be beneficial to look at some of our PQP results across cell technologies as reported in the 2023 scorecard. So we reported strong results from TOPCon and HJT, although as it says, the sample sizes for TOPCon and HJT weren't as high as those for PERC. So we're not quite ready to say that those technologies have matured and that the results we see on somewhat the new adopters are representative for the results across all TOPCon or HJT. So that said, in thermal cycling, we saw that PERC and TOPCon both showed strong results, but we also on the HJT side saw that some bombs are still needing to work on improving the low temperature soldering that's required for HJT. It's a very different soldering process than PERC and TOPCon. Some manufacturers can do it very reliably. Other manufacturers have some work to do. We didn't see meaningful cell technology related differences for damp heat this past year or mechanical stress sequence or even PID as reported in the 2023 scorecard. Although we did report that for PID, some PERC bombs have experienced some difficulties with regard to polarization that occurs during PID testing. And to build off that, in our more recent TOPCon PID testing, we have seen a few issues start to emerge. So that's one test to look out for on TOPCon modules. For LID and LETID, the non-PERC modules really shined with an average power loss of 0%, which, we first thought that was a typo, but they really have 0%. CADTEL as well, 0% LID and LETID on average. Further, 100% of the PERC bombs we tested for the 2023 scorecard used gallium dopant, and those results were also improved over past boron-doped PERC. And finally, at the bottom there, for PAN performance, here we see that the improved temperature coefficients of TOPCon and HJT, as well as the higher bifacialities of those technologies, which isn't stated here, but we did see that. There's a real improvement across temperature coefficients and bifacialities for N-type. One thing that we didn't see was low light performance improvements. We didn't see a meaningful difference across different crystalline cell technologies for that aspect. And then just briefly digging into a bit of a case study here on a PERC versus TOPCon PAN results. These are two modules from the same module manufacturer. There's only 18 months between the factory witness of the two models, but within that time, by switching to TOPCon, some great performance improvements. You can see in this graph here, the temperature coefficient for TOPCon is better at 0.30 versus negative 0.32. In this case, the low light performance was also much better. And the bifaciality is 10% higher for TOPCon versus PERC. That all results in a higher energy yield for the TOPCon bomb versus the PERC bomb, both in Las Vegas. That's our simulation there, which is a desert environment. And then in a more temperate environment of Boston, there still is a 1.1% higher energy yield there. And for anyone building projects or financing projects, you'll know that the 2.3% higher energy yield in Las Vegas is a huge improvement that across a 500 megawatt site could be worth millions of dollars. So definitely TOPCon has better performance potential than PERC. And on this final slide, I'll just quickly focus on Trina's inclusion in PVEL's PV module reliability scorecard. As you can see along the side here, Trina has been listed in all 9 scorecards dating back to 2014. And in this GIF here, you can see how in the scorecard, you can search on different module manufacturers or different metadata on the modules. And this shows you the Trina modules that were top performers. So showing that again, scrolling down, you can type in under manufacturer name Trina, or really any manufacturer, but this is Trina's webinar, so we're focused on them. Trina, and then it will load up what the top performers are, their module design specs, the cell technology. You can even export that as a CSV, etc. So go check that out. It's at scorecard.pvel.com/top-performers. And that's it from me for now until the Q&A session. But please make sure, again, to head to scorecard.pvel.com. You can just scan that little QR code to learn more about our PQP testing, including case studies from the field, historical trends, lab results examples, and of course, the top performers, including our hosts here with Trina. So thanks very much, and I look forward to your questions.
Fantastic. Thanks so much, Tristan. And yeah, of course, you say you look forward to questions. I can confirm that there are already some questions coming in for you, I think. And certainly, having worked in solar media for some years, I can certainly attest that every edition of the PVEL scorecard is eagerly awaited by our readers and of course, the broader industry. So Jason, hi there. It's time to turn over to you. So you'll be talking about the power rating challenges for the N-type PV modules. So yeah, if you'd like to start your presentation, go ahead.
Yes, thank you, Andy. So dear colleagues from PV industry, I'm Jason Gao from TÜV Rheinland, and thanks for the invitation from Trina Solar and PV Tech. I think my colleagues Zero and Tristan have already introduced the roadmap and the reliability testing of N-type PV modules. So now I will give you a presentation about the measurement of N-type PV devices. So my report will cover the contents of the hysteresis and the metastability effects, the spectral mismatch, the IV corrections of N-type PV modules in the measurement, and our cooperation with Trina Solar about the measurement technologies of N-type PV module. So first, let's introduce the N-type. So thanks to the development of the N-type wafer production and the progress of the passivation, back contact technologies, we will see a repeat development of the N-type module market share in the next 5 to 10 years. So now in the N-type module market, we can find several PV technologies that are in mass production, such as the TOPCon, AGT, NBC, and PERT. So, and the TOPCon is still the mainstream in the N-type technologies. So today we will mainly talk about the power rating, so-called the measurement of the N-type PV modules. There are a lot of factors affecting the accuracy and the measurement uncertainty of PV modules. So today we will not talk about them one by one, since there are a lot of factors. But compared to the P-type PV modules, mainly for the PERC, the main problem of N-type PV module are centered on the operation technical and the measurement procedure, especially for the calibration and the measurement procedure, the IV corrections, spectral mismatch, and the metastability. So now we will introduce them in detail. So in our TÜV Rheinland, we have been working on the N-type module measurement technology development for many years. So our main disadvantage and capacity includes the first, stable traceability. We calibrate the solar simulator based on WPI cells traced to PDB Germany with a stable calibration record for years. And we attend in or organize the international round-robin measurements and test once per year to make sure the measurement results are stable. The second is the hardware. We now have 3 AAA A+ solar simulator in Shanghai lab. for the TC or other power measurements. Yes, in our global labs, there will be more. The high accuracy spectral response tester for the SR measurement, and then used for the spectrum mismatch calculation, and the automatic measurement system for the PV module under different irradiance and temperature. The third is the software. We developed our own software to operate the solar simulators and process the data with advanced technologies, and combine our patents, dynamic IV method, and multi-flash. So for the spectral mismatch calculation and other parameters extraction, we also programmed the corresponding software. Based on all of these advantages, we can both respond quickly to the new measurement technologies and standardize our testing procedure. So next, we will talk about the difficulties in the measurement of N-type modules. Hysteresis is an old topic for the high efficiency PV module measurement. For N-type, yes, it will be more severe. So normally we will use actively controlled electrical load to measure the IV curve of the PV module. So a difference between the load voltage and the module output voltage will cross the hysteresis error due to the capacitance. So for N-type module, the hysteresis effect can not be eliminated in tens of seconds of flash time by simply use the multi-slope method or the nonlinear sweep method. So with our patent dynamic IV method, we can measure the stable current value and certain voltages, and get the capacitance-free IV curves. This is international round-robin measurement result for the hysteresis effects. The round-robin actually was organized by TÜV Rheinland and Trina Solar, and 10 top labs in Asia, Europe, and North America attend the round-robin and using the different measurement method. So the EN value for the Pmax of TÜV Rheinland is within plus minus 0.15 and defined ISA. So actually the suitable value is about plus minus 0.5. This should be enough. So here, the metastability is kind of the new problem for the N-type module. The metastability was first found in the measurement of AGTP module. The rated power can increase 1 to 2% after 5 to 10 hours light shocking. And for some PV modules after the light shocking, the IC and Pmax can increase and then gradually decrease in dark conditions. So we call it metastability. So metastable effects pose challenges for the measurement of PV module in third-party labs, and the simulators check on production lines. So we have already found some TOPCon PV modules showed up to 2% error in STC measurement due to the metastability. Okay, then since the spectrum of the solar simulator cannot be perfect AM 1.5 defined in IC 60904-3, so the spectrum mismatch correction is necessary to the accurate measurement of the PV modules. The calculation is defined in the IC 60904-7. So there is an analysis based on the data from our TÜV Rheinland database. About 8,000 situations were considered. So compared with the BSF PV technologies, the high efficiency PV modules always show higher spectral mismatch factor. For example, the TOPCon PV module, even with the A+ spectrum, the spectral mismatch factor can be about 2%. When with the A-class solar simulator spectrum, the spectral mismatch can exceed 3%. That's why spectral mismatch correction is necessary for the accurate measurement of the N-type P modules. Well, the IV corrections actually is the final step of the power measurement of P modules. It is used to convert one IV curve to another IV curve under certain temperature and irradiance. So normally, this process will be accomplished in the software. So the methods are defined in the IEC 60891. Normally, we will use the correction method, procedure 1 and 2, and procedure 2 is more accurate. But we just update the procedure 2, meaning because there are some new feathers for the high efficiency PV devices, especially for the N-type PV modules. Before, we can use the first order model to fit the VOC and irradiance, but now the quadratic fit is more suitable, and the temperature coefficient of Pmax are very different under each level of irradiance, so we need to correct it with nonlinear radiation. So this the new formulas. Now it looks more complicated, but with the new procedure 2, the accuracy of VOC increased 2.5%, and the accuracy of Pmax increased 0.3%. Well, TÜV Rheinland and Trina Solar are now cooperating on the development of the advanced measurement technologies for N-type modules. We hope it can help regulating the N-type module measurements. Related international round-robin measurement is on the way, and today, we just received some results. We both released some of the measurement results recently, which shows the efficiency of different PV technologies from last year, and Trina also sent us some monitor data in different measurement labs. It shows in TÜV Rheinland is very stable. So the power measurement of N-type PV modules are affected by several factors, as I introduced in my presentation. Completed traceability chain, the correct measurement measures such as dynamic IV, and the standard operation procedure are the key to ensure the accuracy measurements of the PV module. Cooperating with our clients, we will release our measurement results and round-robin results periodically. So thank you. This is my presentation.
That's fantastic. Thank you very much, Jason. And yeah, I'm pretty sure a lot of the audience were paying the attention that you're thanking them for there, because there's a few questions in, I think, for TÜV Rheinland in there. So folks, if you could put your cameras back on, please, and unmute your microphones and join me for a quick discussion. That's great, thanks. So yeah, let's start off with well, in the order actually that we saw your presentation. So Theo, yeah, I mean, the theme of this is really around N-type TOPCon, but as we all know, there are many new cell technologies that have come out in recent years, but many major players are choosing TOPCon, and as you said, there's, I think, more than 50% now of dedicated capacity going forwards is going to be that technology, and Trina Solar is, of course, one of those major players. So yeah, you explained this a little bit, but why TOPCon from your point of view?
Yeah, thanks, Andy. This is a pretty good question, I think. Just as I mentioned in my presentation, Trina Solar started research on the TOPCon technology early as in 2015. It's very early. And in fact, not only the N-type TOPCon cell technology is a manufacturer who has already dedicated itself in the solar industry more than 25 years. Trina Solar has also did the research on the others possible N-type technology. With the passing of the time, we believe that TOPCon is getting more and more popular. We can see in the industry right now, and the actions and the capacity of the main players right now also prove that this technology has already become the main technology routine so far. Compared to the last generation, the last main player, the mainstream technology PERC. So Trina's technology research and development team also believe that TOPCon is the best option in the next few years, which that is a conclusion drawing from a comprehensive consideration of all aspects. Thank you.
Yeah, absolutely. And I think if I'm not putting words in Tristan's mouth, I think some of the things that were found through extensive testing showed that there's a continuing potential as well, I think, for TOPCon to continue growing and of course improving. And Theo, in your presentation you mentioned 2015, so not quite 10 years obviously, but still pretty early to be engaging with this technology. And Trina Solar is creating this sort of iTopCon brand, I guess you could call it, or type of technology anyway. So you mentioned that there's 4 generations in already, and of course Trina Solar you're still doing the research on this. So yeah, could you please introduce a little bit of an update in what goes into the newer iTopCon compared with the last generations, and perhaps tell us a little bit about the evolution, no pun intended there, Tristan, the evolution of the TOPCon technology, and also tell us a little bit, if you can, about Trina's Vertex PV module and how that has really evolved.
Well, okay, thanks, Eddie. Another good question, I have to say. Including the iTopCon and iTopCon Plus, iTopCon Advanced, we have already upgraded in the 3rd generation, which I have already shown in my presentation. This is we believe that this is a process of keeping research and practice about the cell technology. And like what we have right now, for example, we developed the selective emitter technology and backside microstructure reflector, as well as PVCVD to replace the old one, the LECVD, is in the 3rd generation of iTopCon advanced technology. Those technology innovation help to increase the cell efficiency, like the iTopCon advanced technology to compared to the last generation, the Plus, the cell efficiency in mass production can from 24.5 to 25.5. This is a great upgrade. And of course, in the module, our Vertex N production family, the power getting higher compared to the last one, no matter in scenarios of rooftop, residential, as well as the utility, the big size. So and we Trina Solar, we believe that we are still working on the next generation, like Ultra and the Tandem technology, shown in my presentation as well. This is expected to coming after the 2025. Around this time, its cell efficiency could be exceed 30%. So overall, this is a long way, I believe, but the Trina Solar will keeping research on that. That's it.
Yeah, I mean it's so exciting watching that these changes and advances as they come, I think. And I think as you mentioned, the LCOE, levelized cost of electricity, continues to go down. The efficiency continues to go up, and yeah, I think when we hit 30%, that's a real big milestone, really, I guess, for the industry and in power generation through clean energy. But one other thing I've noticed is that every year we go to these trade shows, or we go to visit production sites or projects, and the modules get bigger and bigger. And so a couple of years ago, or even last year, I guess, after coming back from a couple of years away because obviously of COVID, I see 600 watt modules and what have you. And now you have modules that are more than 700 watts. So is it just be interesting to know if you think that will continue increasing, particularly in the utility scale, in terms of size and module output, or if there's perhaps a sort of optimal kind of size to get to for that, do you think?
Yeah, thank you, Andy. Well, yes, you can see now our big size module is up to the 710. No matter on the Trina's. In fact, the Trina is the first group who developed the 210 wafer, and the module can up to the 700. I think it's thanks for the innovation of our 210 millimeter cell. The module design now can be bigger and the power can exceed 700 watts. In fact, in the time of the P-type, Trina's the DEG21 series product is the first one whose power exceeds 600 watts. And since then, we have the time of a higher power module. We believe that is the trend with the development of the technology. If the cell making breakthrough on the efficiency, of course, the power will increase on the module. We have the size design of 2384 with 3003 millimeter. Considering both power and reliability, we believe that now this is the best design for the utility, And thinking about years ago, like 2009 and 2010, at that time, the power of the module just around 300 watts. And so I believe that the power of the module will keep higher and in the future, especially for the utility.
Cool. Okay. Yeah. I mean, it's definitely a development that we look forward to continuing to cover. But yeah, that's not to say, I mean, obviously 700 watts plus, that's already pretty impressive anyway, isn't it? Let's say that too. Okay. So yeah, some questions for you, Tristan, at PVEL. And we've got as I said, the module scorecard is something that the industry has really come to, look forward to every year, really, I guess. And it's in its 9th year of providing data that's abundant and research the industry, and it makes an important contribution to the development of solar technology. But one aspect of it that you mentioned is the product qualification program, or PQP. Could you tell us a bit more about the purpose of that and perhaps why extended reliability tests are important? And, as a little, let's say a little adjunct to that as well, if there's any kind of changes or evolutions in the PQP that are on their way, a bit of detail and a bit of light on that would be appreciated.
Sure. So, I've been in the solar industry since 2011, and I've seen the importance of extended reliability testing throughout that process, both as a manufacturer to prove our claims. Trina, using them as an example, they obviously talk about how reliable their modules are. Having a third party data to support that is important. Certification testing does not go far enough to answer the question of, is this a good investment to stick out in, millions of these panels in a field, like in the picture we see here on the screen, or even, a couple dozen of them on my rooftops. Certification is, setting the baseline for manufacturers to participate in the industry with their products, but it doesn't answer, is this a good investment, a safe investment, a reliable investment, a durable module. So that's what we're trying to do with our product qualification program. And then those results, because we think it's important for the industry to learn from what we're seeing, those results go into the annual scorecard. So none of our test results are in the scorecard unless it's part of our product qualification program, which is a known test program that includes the factory witness, as I mentioned earlier. And, we don't allow manufacturers to pick and choose their tests. I mentioned, us seeing issues with PID on some TOPCon modules recently. We don't allow those manufacturers to say, well, I want to do all of the other tests except PID. You have to do it. PID is a core part of the PQP. You've got to do it if you want to be listed in the scorecard. So that's how it's, more of a program than just a simple test plan. Now, in terms of how it's evolving, as I mentioned during my presentation, we are releasing an updated PQP. It was supposed to be in October. It might slip into November, but as soon as possible, hopefully within the next 30 days. And that includes some tweaks in, how we mount the modules during mechanical load testing. That's becoming, we're going to use a more aggressive mounting. Is an example. Another example is LETID. We don't see much effects. I've reported, in my presentation, 0% LID plus LETID for TOPCon modules. So we're actually shortening that test. We think it's still somewhat important, but it doesn't need to be as long as it is. And then there is industry reports for of UV-induced degradation. So, if you're sick of hearing potential induced degradation and light-induced degradation and light and elevated temperature-induced degradation, well, I got another one to add to your list, UV-induced degradation. So we're adding a test to check for that and see if modules are susceptible. There's some other changes too, and we'll be releasing a press release, and I'm sure PV Tech will pick up on that story. So keep your eye out on PV Tech and pvel.com to see those changes coming up.
Absolutely. So in other words, I guess it's important to have a standardized sort of set of rigorous criteria and testing that you can compare in a transparent apples for apples comparison sort of way, I guess, but then also to keep updating that, really, I suppose, as it goes. And, and well, the industry's already got plenty of acronyms, so I'm sure there's room for more as well when it comes to UV-induced degradation as well, Tristan. So, but specifically on, so you mentioned Trina Solar's activities and work together, in developing kind of modules that are scoring pretty well, so I gather. But the long-term partnership between Trina and PVEL has been in place for a while, but also separate to that, Trina Solar has been on the top performer list for 9 years in a row. And it was on the top performer list, I believe, for the 2023 scorecard. So could you maybe just dive a little bit deeper into how the Trina Vertex N-type modules performed?
Yeah, so you can see that in the GIF I displayed for filtering on Trina Solar's results. And I'm actually just pulling that up on my computer here. I won't share my screen, but we have tested, both their PERC modules and their Vertex modules. Their PERC modules, and Vertex is PERC, but their Vertex Plus, their N-type modules. Their 19 series for the N-type modules. They were a top performer in multiple categories, so you can see that in the scorecard. And they weren't listed in thermal cycling as a top performer, but I will report that was because that test is one of the longest ones, and we weren't finished by the time the scorecard was released. So they were actually a top performer in thermal cycling as well. So basically across the board in all the reliability tests, we saw strong results from Trina's TOPCon modules. And we have some of their other modules, like, for example, the residential N-type module that's currently being tested now at our lab. We did not start that in time for the 2023 scorecard, but it is undergoing testing currently. So we typically, because Trina is a long time supporter of PVEL's testing and vice versa, we typically test across their product portfolio, and the scorecard represents a moment in time. But feel free to reach out to us, sign up as a downstream partner, and you can keep track of the more recent results across Trina and other manufacturers' testing.
Excellent, excellent. And it's just another reason why we're obviously delighted to be working with Trina Solar on this very webinar. But going to let's say a slightly more general question, and this is one that I was looking to ask you anyway, but I note that it's something that quite a few of the audience members are asking as well. So yeah, I'd be happy to ask their question as well as mine at the same time, I suppose. But yeah, Tristan, you mentioned some of the advantages of TOPCon over some of the other technologies that are available, but specifically over HJT, heterojunction technology. Yeah, what are the advantages that TOPCon has over those with regards to reliability?
Yeah, so I think, reliability aside, I'll talk about that in a second. I think going from a PERC cell manufacturing line and a PERC module manufacturing line to TOPCon is much lower of a step. Basically, a TOPCon manufacturing line for modules and a PERC line are the same thing. And on the cell line, you have to introduce a couple extra pieces of equipment to turn a PERC cell into a TOPCon cell. HJT is a whole different beast. HJT, you're not upgrading your PERC factory, you're creating a new cell factory. And similarly, on the module side, it uses different soldering for the cells. The back end, after lamination is quite the same, but the front end cell soldering process for HJT is quite a bit different than TOPCon and PERC. So I think that's why we're seeing manufacturers gravitate more towards TOPCon. It's a smaller step from PERC to TOPCon than from PERC to HJT. And then on the reliability side, we see that, as I mentioned earlier, for thermal cycling, we see really strong results for TOPCon. The range of results is greater for thermal cycling for HJT because of that new soldering process. The production window for that or process window is quite a bit tighter for HJT than TOPCon. Both of those modules are not big fans of moisture, so there are damp heat risks for both of them. I would say there's also PID risks for both of them. You can dig into the scorecards and reach out to PVEL if you want to learn more. But generally speaking, there's a wide range of results for new technologies. I think TOPCon is probably, for a number of manufacturers, more mature than HJT. So those results are tighter than for HJT. But we've seen examples for both of manufacturers doing them quite well and manufacturers still needing some work to do.
Excellent, excellent. Okay, well, yeah, comprehensive, but very succinct answer there, Tristan. So, Jason, if I could just ask you a few questions as well, please. Really fascinating presentation you gave, and I think many of our audience were really hooked on it. But just thinking about the measurement accuracy of the N-type PV modules, because obviously a lot of the decision making comes from the testing, and so that's clearly, as we've seen, is super important. But yeah, so between traceability methods and measurement methods, which one has a larger impact on the measurement accuracy of N-type PV modules?
Well, actually, this is very good questions, and so if we can consider these two issues separately, so for traceability, the difference of the reference PV devices and the solar cell simulator calibration method can cause about 1 to 2% error in the measurement, and only for the measurement method, the hysteresis effect, the metastability, and the spectrum mismatch can all cross about up to 3% error. But most of the time, we need to take these two, the calibration method and the measurement method together. So like in IC 60904-2 simulator, calibration can be based on Pmax or IC of the reference device, but actually in production line and some third-party lab, the calibration is based on both Pmax and IC. So if the hysteresis effect cannot be eliminated in the simulator calibration, then the rationality of the traceability will also be very difficult to assess. Yeah.
Okay. And yeah, I mean, one other thing is you're talking about evaluating the metastability characteristics of N-type PV modules, and yeah, what are some of the ways to, or what are the ways to evaluate those characteristics, Jason?
Yes. I already mentioned the metastability is actually a new problem. So, but I think it's necessary to say that the metastability, just like the hysteresis effect, it's not a disadvantage of the PV devices. It's just the problem in the measurement. So, for some crystalline silicon PV modules, the rated power can increase after the lead shocking or the current injection. The rated power before lead shocking and it's the power just after the production line, and the rated power after the lead shocking is actually the real power in the field. So although the metastability was found in the measurement of the HJT module, but the HJT module is actually not so sensitive to the metastability. Since we can see the complicated the metastability behavior after 5 to 10 hours lead shocking. However, for some top count module, the metastability can be seen even after several seconds of the lead shocking. So actually, for some top count modules, it is more sensitive. And now there is no related evaluation method for metastability in IC standard. In our lab, we will take two measurements before and after the lead shocking or current injection for this kind of modules. But how to use this kind of module as a reference module in the production line is still challenging. I think the PV manufacturers need to take these issues seriously.
Okay. Thank you very much, Jason. And you know, for your big picture overview, I guess you know, there's been a lot of rapid developments in the past several years, but what are your views on some of the new technology trends, and what do you think are the important aspects of those new technology trends from the perspective of independent third-party labs such as yourself?
Yes, in these years, we saw a lot of PV technologies from lab to mass production, but also more severe difficulties in the PV measurement, just like the topics that I already introduced, like the hysteresis, metastability, the spectrum mismatch, and the non-linearity of the PV module behavior. So first, I agree, Zero and Tristan, the TOPCon will dominate the N-type PV market, or even the whole PV market in the next 3 to 5 years. So compared with P-type module, the N-type module normally has a lower temperature coefficients and better low irradiance performance. So which means higher energy generation in the field. So TOPCon has a good balance between the cost and these capabilities. For other N-type PV technologies like AGT, the energy yield in field is good, but the cost is still a problem. for some NBC PV modules, there's some new technologies from last year. Since the service resistance of this kind of PV module is always very low, so that TCA power is very high, but the low irradiance performance is not so good. So, however, this we cannot say that technology is not good, but I think the technologies also have the opportunity to achieve a more balanced performance with the parameters optimization in the production line. I think the balance of the ITC power, the temperature coefficient, the low irradiance behavior are the I think it's the most important thing for the modules.
Excellent. Thank you so much for that expert perspective, Jason. Okay, so we've gone a little bit over time, but there are still a lot of people on this call, so we will try and do a few audience questions now. All right, so something we've been hearing a lot about is need for weatherization of PV plants, and the need essentially for plants that can withstand some more extreme weathers, which unfortunately we're seeing. So audience member Kamal was asking about module reliability, especially in hail conditions. And I know that's something that PVEL does test for as well. So is anyone able to take that one on?
Yeah, I can certainly speak to that. We covered that in the scorecard. Basically we're seeing that glass modules break more during hail than glass backsheet modules. So with glass backsheet, the glass is fully tempered. Glass 2 millimeter or 1.6 millimeter glass, it's not fully tempered. I think you can probably safely withstand a 30 or 35 millimeter hail impact with glass modules. But once you get up to 50 millimeter hail impact, the failure rate on glass is about 90%. And on glass backsheet, I think it's about 35% fail. So the majority of glass backsheet modules can pass that 50 millimeter hail. So it really depends on where you're installing your modules. In some regions, you're never going to see, well, I shouldn't say never with climate change, but you're unlikely to see 50 millimeter hail. In other, hail regions, you really need to have, between your hail monitoring, your hail/weather monitoring, your stow angle and hail stow approach, as well as your module selection. All of that can help dictate how well your site survives basically a hailstorm. But again, in other regions, it's not really a concern. So it really depends on where your project is.
Okay, and we had quite a few questions about PID, potential induced degradation. So audience member Nityanand was asking if N-type PV modules are PID free or not, and there was another question in there somewhere, but we've probably not got time to read through the whole thing. But would anyone like to answer briefly on the response of N-type modules to PID issues at all?
Well, going back to the modules that were top performers for Trina in the 2023 scorecard, their N-type modules had less than 2% degradation following PID testing. But as I previously mentioned, we've seen other modules with higher levels of PID, and I would say, a concerning amount of PID. So, I wouldn't say that N-type modules, whether it's TOPCon or HJT, are, intrinsically not susceptible to PID. Some manufacturers can make ones that we don't see any PID issues in our testing. Others, quite the opposite. So, you know, it really depends on how you're manufacturing the cell, what encapsulants you're using to determine whether the modules are PID susceptible or not. It's not just, well, I'm going to switch to TOPCon or HJT and never have to think about PID again.
Okay, and we're kind of, I mean, clearly we are here to, well, largely talk about N-type TOPCon, but Tristan, I think one audience member, so Fiona, was interested to know what you meant in the, I think it was a comment about some HJT heterojunction technology needs improvement. So anything you can elaborate on that for us briefly?
Yeah, I mean, I've mentioned that a few times. So that was specific to the thermal cycling results, which is essentially a cell soldering test. It looks at other things, but cell soldering is definitely part of it. And I mentioned that, you know, the HJT requires low temperature soldering. If you use the standard soldering for HJT that you would use for TOPCon or PERC, which is higher temperature, you'll destroy the layers on the HJT cells. So you have to use a low temperature soldering process. For some manufacturers, that's a brand new process for them, and the results might not be as good as for some other manufacturers or for their traditional, you know, PERC or even TOPCon cells. So that's what I was referring to there, is that yeah, that cell soldering for HJT might be pretty tricky, and it's got to be a process that's dialed in by the manufacturers. Now, that said, again, like all of our testing, we see results that are great and results that are not so great. So I'm not trying to say intrinsically HJT can't be soldered properly. We have examples of that not being true, and top performers for thermal cycling for HJT modules. But it is a risk that manufacturers need to address.
Excellent. Thanks very much, Tristan. Okay, folks, I think we're running out of time a little bit here, and yeah, do appreciate everyone's time very much. Thank you so much to all the audience that engaged with us. I see we didn't answer all of the questions as expected. We had lots of great questions come in, but Trina Solar will be happy to follow up offline with all of those and yeah, get those questions answered, including Theo. I note a potential customer who wants to buy lots of modules for tenders they're participating in Southern Europe. So I won't name them or anything like that here, but it's pretty exciting to see that happen in real time, isn't it? It's pretty cool. Okay, all right. Well, yeah, I just want to most of all thank our audience. Thank you so much for being here, and also I want to say that, you know, you are all of you, I think, working really hard in an industry that's you know, not only very positive for environment and positive for future generations, but also just a really exciting, really cool technology. So thanks so much for being a part of that, I think, from my perspective. And also I want to thank our speakers today, Theo from Trina Solar, Jason from TÜV Rheinland, and Tristan from PVEL. Thank you so much for your time, and we look forward to seeing you the next time we will meet and discuss, well, these sorts of matters, and I hope it will be just as exciting next time as well. Thank you very much.
Thank you.
Thank
Bye,
you.
everybody.